All right, let's take a look. So I'm going to do 6-4 first, okay, and then we'll jump over to 6-3. So the problems I'm picking are right from the homework from 6-4, and I'm hand picking them. All right. The reason I'm hand picking them is because you're going to see them on the quiz tomorrow. So let's make sure we're good with this. Let me just double check something here. Yep, let's do that. All right. So look at 1, 2, and 3. Whoops, wrong thing. There we go. All right, so you got this little rectangle. You got some diagonals in the rectangle. I don't think I'm going to do all 3 of these because they're kind of the same. So maybe I'll just pick one of them. Let's pick 2 or 3. Let's do number 2. Okay, so this is from the homework from 6-4. This is number 2. Let's put some letters in here. PQRS. And then put a T right there in the middle. All right. And here's what they tell you. They tell you that QT equals 5. And they want you to find PR. Find PR. Okay? It should be easy if you know the geometry concept, okay? You know what's true about diagonals in a rectangle, and they tell you that this is a rectangle, all right? So they tell you that this is a rectangle. So what do we know about the diagonals of a rectangle? Anybody remember? We just did it. Look in your notes. If you got your notes out, flip back a page or so, and you should be able to see it. They're congruent to each other. That's right. They're congruent. The diagonals are congruent, or they're equal to each other. That means that PR equals what? QS. Very good. Everybody see that? So this diagonal right here from that corner to this corner, PR, is equal to this diagonal from this corner to this corner, QS. Everybody got that? Make sure you understand that. And they also do what? Since it's a parallelogram, what do the diagonals of any parallelogram do? They intersect each other, but more than that, what do? They bisect each other. Okay, you got to remember these things. These are things you got to keep up with. You got to keep studying. There's so much we're adding every single day. We add new stuff, new stuff, new stuff. You got to keep up with what we're doing. Okay, don't get left behind. All right, so keep up with what we're doing. That's what I'm trying to do now, and that's what quizzes are. Okay, quizzes are trying to get you caught up. They just give you a little incentive to learn this stuff. All right. So the diagonals are equal to each other and they are perpendicular. They're not perpendicular. Don't write that down. They bisect each other. So watch this. If they're equal to each other and they bisect each other, then look, these two are equal. Everybody see that? And these two are equal. And in fact, all 4 of them are equal to each other. Because if I take PR and split it in half, and I take QS and split it in half, I'm taking the same line segments. The same exact line segments and splitting them in half. So that means all 4 of these things are equal. Do you have a pass for me? Who didn't give you one?
I was about to come in, but I spilled syrup on me.
So you didn't leave culinary late. You were in the bathroom.
No, I did leave culinary late. But I was about to come in.
Is he still here? Is he still here? Well, you got to get a pass next time. All right, let's go through this. Look, all 4 of these are equal. So what do they give you? QT. Where's QT? QT is this little bit right there. It's 5. What do they ask for? PR. Okay, now watch this. Check this out. On a rectangle. This is only true about a rectangle. Everybody understand this? It's only true about a rectangle, but all 4 of these segments are equal to each other. So if this is 5, then what's this? That's 5. What's this? And what's this? Okay. Now, what do they ask for? PR, from P to R. So that's 5 and that's 5. What's the whole thing? It's 10. All right, easy. 5 plus 5. Super easy. Agreed? Yeah. All right, so you'll have, how many do you have like that? You'll have 2 of them that are similar to that. We good? Sure. Let's do another one. Oops, let's go to right. All right, let's take a look at number 5. 5 is a 4-part question. Oops. It's got a diagonal as well. But this time, we're looking for angles instead of the lengths of the diagonals. All right, so we're dealing with angles this time. Again, they tell you it's a rectangle. So what do we know right off the bat, without knowing anything else, without me putting anything on here? What do we know about this being a rectangle? 4 right angles. Good. That's exactly what I was looking for. So you got 4 right angles. So all 4 of these are right angles. Okay? This is A. They do bisect each other. That's good. The diagonals bisect each other. Okay? And the diagonals are equal to each other. But this time, I don't care about the diagonals necessarily. Okay? They're going to ask a bunch of stuff about the angles. All right? So let's put some stuff in there that they tell you that's angle 1. They tell you that's angle 3. This one is 2. This one is 35 degrees. So that's all the stuff they tell you. Yep. And here's what they ask you to find. They ask you to find all this stuff right here. So they ask you to find angle BCD. Let's write them down. Angle 1, angle 2, and angle 3. So this is what they're looking for. 4 things. On the quiz, I asked for 2 things, not 4. Yep. All right, so I asked for 2 of these things right here. Okay, if you know how to find all 4 of them, you should be able to find the 2 that I asked for on the quiz. I'm just not going to tell you which ones on the quiz I'm asking for. All right, and that's all they tell you. They don't tell you anything else. So where do we even start? Well, let's take a look at the first one, BCD. Let's figure out what angle that is. Well, there's B, there's C, there's D. All right, so if I go from B to C and from C to D, what's that angle?
90.
It's 90 degrees. Without doing any work at all, you should be able to figure that out. Would you agree? Because it's a rectangle. We knew that right off the bat. That's why I put that little 90 degree. So angle BCD is 90 degrees. Oops. Do you see that or not? Let me know if you don't see that. Angle BCD. In the other class, somebody said it was 35 degrees. But that's not BCD, is it? What is the 35 degree? ACD. Good. All right. What's the BCD? BCD is this angle right there, which is 90 degrees. Josh. Yep. Yep. That's 90 degrees. You got it? No math involved. Super easy. I hope that's on the quiz, don't you? Okay. I mean, it might be, might not be. All right. The next one, you don't have to do any work either. Angle 1. But let's look and see why.
35.
How do you know it's 35? And you are right. It is 35. Give me a reason. What is it? Okay, why are they equal, though? Give me a reason. Now, they're not consecutive. Alternate what? Interior angles. Okay, remember that? And what did we learn? Remember, this is a rectangle, so that means this and this are parallel, correct? There's my transversal. So look, this and this are alternate interior angles. Remember we did that a long time ago? This thing right there. So where's this 35? It's above the parallel one, below the transversal. So it's that right there. That's your 35. Which one's your angle 1? Well, it's below the transversal and it's below the transversal, above the it's below the parallel line and above the transversal. Remember this? So those 2 angles are alternate interior angles. It's the same here. So angle 1 and 35 are alternate interior angles. What did we learn about alternate interior angles? They're equal to each other, congruent to each other. That's right. So they're the same. So angle 1 is, without doing any math, 35 degrees. But you had to know, I mean, you didn't have to write down that they're alternate interior angles, but you had to remember that that's the relationship between them. All right, what about angle 2? Angle 2 is a little trickier. So watch. I want to find that one right there, that yellow one. You watching? You thinking? I don't think you're thinking. I think you're just waiting for me just to show you how to do this. I want you to think. I want you to concentrate. That'll stop you from talking if you're concentrating and thinking about this. So how in the world do I find angle 2? Well, it's part of that 90-degree angle, isn't it? All right. So what if I knew this angle right there? I'll put 2 arcs there. What if I knew this angle? How would I find angle 2? Just how you say it. You're about to say it. What if I knew this angle? From? You just said it. Say it. From 90. That's right. But I don't know that angle. Justin, were you going to say it? How do I know this angle right here? How do you know that's 35? Okay, because the other one's 35. Now watch very carefully. Now look, you don't have to go through this big explanation on the quiz or test. All right, you could look at it, and if you just guessed that that was 35, it'd be a good guess. All right, let me show you exactly why. Because remember, we said all 4 of those things were equal to each other. So look at this triangle. Do you see this triangle down here on the bottom, in the middle? Yeah, this triangle right here. See it? Yes? I'm not getting much response. Okay, thank you. All right, so you see that triangle. If I have 2 sides of a triangle that are equal to each other, what's true about the opposite angles? They're going to be equal to each other. So if this is 35, this angle opposite this side is also going to be what? 35. Now, how do I find angle 2? Well, it's not 35 minus 90. Take the bigger one, 90 minus 35, and what's that? That's 55 degrees. Okay? You know how to do that? Borrow 1 from the 9, right? Put it right there. 10 minus 5 is 5. 8 minus 3 is 5. Okay, so that is 55 degrees. That's what this angle is right there. All right? So that took a little thought, took a little extra thought. The first 2 were pretty easy. Well, it's all one problem, but what did I just finish saying? I'm only picking 2 of these for the quiz, all right? But on the homework, yeah, this was all one problem. What about angle 3? This is a little bit tough too. So I'm looking for that angle right there.
Oh, 35.
Angle 3 is 35? Look, that's 35. That's acute. Is there any way that that's going to be 35?
Oh, half of 35?
Is it? Half of 35? Yeah, this has got to be way more than 35. It can't even be 70. 70s, it's got to be obtuse, right? More than 90. So if I just add up, because people in that last class said, oh, it's 70, just add the 2 together. No, we will add the 2 together, but that's not what that angle is. Okay, what about the 180? This is 180?
I'm saying, like, it's 180, it means you're adding 180, you're subtracting 180 to 35. Right? 35 to 35.
Thank you. All right, so watch. Let me show you one thing real quick. Do you see how this is 35 and this is 35? Okay. What's this angle compared to this angle? There's a word for it. Anybody remember? Probably not. It's been a while. If you have 2, anytime you have 2 lines that intersect each other, you have these angles are equal and these angles. Thank you. It's vertical angles. Vertical angles are equal. So this angle 3 is equal to this angle down here, the second blue one. So yeah, so you got this triangle, right? So use the triangle. So what do all 3 angles add up to be on a triangle? Any triangle? 180, right? So I already know 2 of them, right? So what do they add up to be? 70. So what do I do? 180, what? Minus 70. And that's going to give you this angle right here. But is that angle 3? Yeah, because they're vertical angles. This angle down here is the same exact angle as this one right here. We got it? Or you could have done this. You already knew that angle 1 was 35 degrees, didn't you? So what's this angle right here going to be? 35. Then you could have found angle 3, right? But you do it the same way, and so what do you get? You get 110. And so that's 110 degrees. So the last 2 were a little bit tougher, just a little bit, but I went through it and I explained why it is. Hopefully you see it. All right, go back, watch the video. If you weren't sure, pause it, think about it. All right, sit there, mull over it a little bit as you're watching it. Hopefully that'll help. All right, let's do some more because we got more to do. Let's see which one I want to do. Number 7 and 8. Actually, I didn't even ask anything about 8. I should have. So number 7. Let's just do number 7. This is a, what is it? It's a rhombus. All right, so you got to review stuff about a rhombus. What do we know about a rhombus? All sides are parallel? What? All sides are equal. Very good. Right, you do have two sets of parallel sides because it's a parallelogram, right? A rhombus is a parallelogram. All right. Let's put some diagonals in there, right? Go from one corner to the other. That's a diagonal, and this is a diagonal. All right, by definition, what do we know about a rhombus? You guys said it already. All the sides are equal to each other, okay? Now, we learned something very recently, I think in the last, maybe in section 6.2 maybe, we learned something about the diagonals of a rhombus. Remember, this is a rhombus, and they tell you it's a rhombus, okay? What else? Without them giving you any questions, putting any numbers in here, let's just remember what we learned about a rhombus. There's two things. If you flip to your notes, that's fine. If you took notes, that's why you take notes. Flip back to your notes. Let's see what we learned. I think it's section 6.2. What did we learn about a rhombus? We learned something about the diagonals of a rhombus. What did we learn? Consecutive angles? That's right. The diagonals of a rhombus are perpendicular. Where'd you get that from, Mario? Your notes? It was from 6.4? Oh, it was 6.4, so it wasn't 6.2. So yeah, it was this lesson that we're doing. I guess that does make sense. All right, so the diagonals of a rhombus are, what'd you say, Mario? Are perpendicular. Okay, there you go. See that? So that's 90 degrees. Everybody got that? Okay. What else do they do? Mario, you're there. You got your notes out. What else do the diagonals do on a rhombus? There's two things that they do. That's it. They bisect the opposite angles. Okay? So what does that mean? That means this big angle right there is being bisected. And so is this big angle right there. Which means what? That this little angle and this little angle are equal. Right. And same thing with these two down here. All four of those are exactly the same. You got it? Okay. With all that said, that was just a brief review on what we did on this lesson with a rhombus. We just did it yesterday, didn't we? Yeah, it was just yesterday we talked about this. So it should be fresh in your mind. All right. Let's see. Let me put some stuff in here. They call this angle 6. This one is angle 5. This is 4. This is 60 degrees right here. This is letter I. That point right there is letter I. And I think that's all they gave you. It is. All right, so they ask you what? 5 things with this. So they ask you to find a bunch of stuff. Now on the quiz, everybody hearing me? On the quiz, I'm only going to ask you for 2 things. But they ask, I think, let me see. Yes, I asked for 2 things on the quiz. On the homework, they asked for 6 things. And let's find all 6. If you can find all 6, you'll be able to find 2 of them. That's that. Angle EFG, EFG. Angle 5 and angle 4, 5, and 6. Angle 4, angle 5, and angle 6. So this is what they want you to find. And here's all the information they give you right here. Everybody got that? So let's do the first one. Let's go in order. FGH. Oops, I got to put some letters in here, don't I? That would help. What is it? EFGH. EFGH. All right, let's try this now. Angle FGH. Start at F, go to G, go to H. So what angle are we trying to find? That whole entire thing. So this should not be that hard. What did we just say about the angles? That diagonal does what to that big blue angle right there? Splits it in two, right? So if this is 60 degrees, what's this little angle right here going to be? That's going to be 60. What's the whole blue angle going to be? 120. It's that easy. Okay? It's almost just looking at it and not doing any math. Almost. You just had to go 60 plus 60. All right? Everybody can do that, can't you? All right, so that's what? 120. Let's do EFG. EFG. Now, Josh, I think you said something. Look at that pink angle and look at that big blue angle. Josh, I'm giving you a chance. You said it earlier and it wasn't right, but now it's going to be right. I think it was you. Somebody said it. Who said it? What's true about this pink angle and this blue angle? They're not the same. Look, that's obtuse. That's acute. There's no way they're even close to the same. What is it? They're supplementary. Remember that? They're consecutive angles. Okay? I forget who said that, but somebody said consecutive angles. They're consecutive. And what's true about the consecutive angles? They are supplementary. Got it? What does that mean to be supplementary? It means they add up to 180. So what was this whole big blue angle right there? It was 120, wasn't it? So that whole big blue angle is 120. What's this pink angle going to be? Right. How do we do it? What math? 180. No, minus 120. And that gives you 60. You were just thinking ahead. All right. So 180 minus 120 is 60 degrees. So that whole entire pink angle is 60 degrees. Is that what they're asking for here? Yeah. EFG is that whole big angle. All right. So that's 60 degrees. You with me? All right, we'll see. All right, angle 4. This one right here. How'd you get 30? Right, because look, this whole big angle is 60. Then this whole big angle down here is what? 60. And so the diagonal bisects that angle. So what's angle 4? It's 30. That's right. So that's 30 and that's 30. So angle 4 is 30 degrees. All right? You just got to know some geometry. You just have to know the relationships, right? That these two angles are equal to each other. So if I found that this was 60, then this has to be 60. Okay, wait a minute. And then I also had to know that the diagonal bisects that angle. So if I split that 60 in half, what do I get? A 30 and a 30. Zion, go ahead.
How do you start out with 60?
I found this. I found.
No, for the LFGA.
They told this one right here.
Yeah.
They told you that.
Oh, all right.
Yeah, they told you. All right. Everybody good so far? Any other questions? All right, let's do 5 and 6. Let's change colors. 5 is super easy. I don't even have to think about 5 barely. I mean, I already marked it. Remember, it's a rhombus. How do the diagonals bisect each other? They bisect each other perpendicular, right? Or they intersect each other perpendicular, right? So it's 90 degrees. Agreed? All right. So what's 5? 90 degrees. Okay. What about 6? Yeah, exactly. You didn't have to do any math at all, did you?
No.
Yes, yes.
I thought the 30. Well, you see the green line? I thought that was like 30, and then the whole thing is 60.
What green one? This is the only green one I got.
That's what I'm saying. Isn't that
That's equal to this?
That's not.
No. Remember, what are equal? The opposite angles are equal to each other. So this, so this big.
So this is 60. And
That's
the
right.
whole thing 120.
Yes. This whole thing would be 120.
So give me this quiz right now.
So watch. This angle E and angle G are the same, right? So you could say, oh, the whole thing's 120, take half of it, 60. But you could also do this. Remember, these two right here are equal to these two right here, right? No, it's just because they're equal to each other, because this is bisecting. Okay, it's bisecting equal angles, right? So if I have $120 and I split that, I get 60 each. If I have another pile of 120 over here, I split that, I got 60 each, right? It's the same exact thing, right? So this is 60 degrees, and this is 60 degrees. So angle 6 is 60 degrees. You're good to go. All right, we got something to do. So that was 6-4. Let's go back to 6-3, and I'm going to do some problems that are on the quiz from 6-3. All right. So that was 6 problems we covered. All right. So now we only have 4 more problems to do. So let me see which one I want to do here. All right. The rest are from 6-3. Is that what you said? Is that what you asked? Yeah, 6-3, 6-4. The quiz is 6-3, 6-4. All right. So here's the first one. It's just a parallelogram. Oops, wrong thing. It's a parallelogram. So let's make it look like a parallelogram. Oops. Okay. And you got, let's see. Now this one doesn't have any diagonals. All right. So I'm doing number 7 for you. This is pretty easy. In fact, I'm not even going to do the math for you. Okay, so this is number 7 on the homework from 6-3. You guys watching? Are you writing it down? Should be, because it's going to be on the quiz. Why would you just sit there with your head on the desk, nothing on your, no papers or anything out when you're taking a quiz tomorrow? All right? Not saying anybody's name, but you know who you are. Here we go. Everybody look up here. Look up here. So if I ask you to solve for x and y, this is on the quiz. All right? If I ask you to solve for x and y, I'm not going to do it for you because there's another problem. Listen, another 2 problems that I'm going to do for you. All right? But this is number 7 from 6-3. You got to solve for x and y. So what do you do to solve for x and y here? Set them equal to each other. And then do some math and figure it out. I'm not even going to give you the answer. I'm not giving you the answer. You do it. I'm explaining it to you right now. Yes, it's algebra. So look. So you go 7x minus 24 equals 3x. You solve for x. I don't think I have to do that for you. I've done that 1,000 times in here. We could just stop right now and not review. Is that what you want? Because it sounds like you guys are finished. Let's try this again. You set these 2 equal to each other, you solve for x. You set these two equal to each other, and you solve for y. So x is your answer, y is your answer. You don't even have to plug it back in to find the lengths of it. You just got to solve for x and y. Okay? Number 8 is kind of the same. I'm sorry, not number 8. Number 2 on the quiz is kind of the same thing, except here's what they do. I'm running out of time, so I need to do this kind of quick because I need some time to do these other problems. See this right here? They give you diagonals, and then they're going to, like number 10. This would be number 10 from 6-3. So if you look at number 10 from 6-3, they tell you this is like b plus 7. They tell you this is 3b plus 1. Now, if this is a parallelogram, what do the diagonals do on a parallelogram? They do what? They bisect each other, which means this b plus 7 and this 3b plus 1 are congruent. They're congruent. They're equal to each other. So you set them equal, you solve for b. Then they're going to give you something with this and this. You set those 2 equal to each other, you solve for a, and then you've got a and you've got b. Right? Pretty basic, pretty straightforward. Now, you better watch on this one.
What, number 9?
Let's see. Which one do I put on the quiz? Number 22. Number 22 and 25 are going to be on the quiz. Numbers 22 and 25 from section 6-3, they will be on the quiz. Let's do number 22 together. Because it's the algebra on these, they're going to cause you a little bit of struggle. It's substitution, not subtraction. Okay? Well, we're doing it. Everybody watch. Everybody watch. I'm going to. If you guys would actually listen to me, I might actually be able to show you. I'm just taking the problem from number 22. So that's 25. This is 6a plus b. All right, and then this one is 20. This is 12a minus b. Now, the geometry is exactly what we just finished talking about. All right, it's the algebra that's a little tougher. So let's set this up. What do I do with these two? Set them equal to each other. So let's do that. So 12a minus b equals 20. Okay? Now, what do I do with these two? Set them equal to each other. So I'm going to go 6a plus b equals 25. Okay? Now, let me show you something I haven't shown you yet. All right? But this is what you can do. You're writing this down? If you're not writing this down, you're basically just giving up on this problem. All right? If you write it down, at least you'll have a fighting chance. Okay? Here's a thing called elimination. In Algebra 1, you should have done substitution and elimination. Okay? Apparently you didn't, but I'm going to show it to you right now. This is set up perfect for elimination. It's elimination because we're going to eliminate. We're going to cancel something out. What I'm going to do is I'm going to write these things down. Make sure the A's are on top of each other and the B's are on top of each other. Okay? Everybody see that? Do you remember doing this in Algebra 1? So watch what we can do. We can add up all three columns. What happens when we add up all three columns? What do we get? 12a plus 6a. Add those up. What do you get? 18a. Now, here's the elimination. Watch. What's negative b plus b?
Oh, that's negative.
It's not a b. It's 0. It's 0. So they eliminate. You're right. That's why we call it elimination. So it eliminates. It cancels out. Negative b plus b is 0. Okay? You see that? That's the elimination. And then equals, what's this? No, you're adding. You're adding these up. It's 45. Okay?
Oh, that's easy.
And then you divide by. Now this one comes out kind of ugly. Actually, does it? Yeah, it does. This one comes out a little bit ugly, but it's not that bad. So divide by 18, divide by 18, and then you work this out. If you wanted to put that into a calculator or something, you get 2.5 or 2.5. So A is equal to 2.5. Now, listen, how do you solve for B? Substitution, okay? You could use the top one, or you could use this bottom one. Let's get rid of this little cross out mark thing. Why would you use this bottom one and not the top one? Because the B is already what? Positive. So what we're going to do is take that A, and then we're going to put it in for that A right there. Hope you're watching because this is on the quiz. So what we're going to do is we did the elimination to solve for A. Now we're going to solve for B. We do that by substitution. So we take what A is equal to, and we replace this A, okay, with 2.5. So let's just write it down here. Is that all right? So it's going to be 6 times what? 2.5 plus B equals 25. Okay? That's what? 18? Or no, that's, what is it? I didn't show my work when I did this. It's 15. Yes, it's 15. All right? Because 2 times 6 is 12, right? Half of 6 is 3. 12 and 3 is 15. All right? That's how I do it in my head. Plus B equals 25. But if you wanted to use a calculator, you could use a calculator. Now, it's super easy. Minus 15 minus 15. B is 10. And there you go. All right? So A is 2.5. It's just like this. I just showed you the steps. Know how to do the steps. Don't just sit there and try to memorize it. Know what you're doing. These two are equal. These two are equal. We got it right here. Okay? We put them on top of each other. You see that? That's important. You put one on top of the other one. Doesn't matter which one's on top. Doesn't make any difference. Shh. Nate, do you understand what I'm doing? I'm waiting for you to be quiet. And you just keep going like you have no idea in the world what's going on here. So let's look. You put these on top of each other. You put these on top of each other, then you add up all the columns. This adds to 18. That eliminates, right? Remember that? And then you add those up, 45. You do your math, you get your A. Then you got to find what B is. So how do you find B? Well, you take that A, and you could put it into either one of these equations. It doesn't matter which one you put it into. I think this is the easier one because you got a plus B. Put an A in for this, and there's your substitution. All right? 6 times 2.5 is 15 plus B is 25 minus 15 is 10. Go through the steps. Don't just sit there and look at it. Don't just even watch the video and just sit there and look at it. Actually have a pencil in hand with a piece of paper, write the problem down, and before I go through doing it, try it yourself. I mean, you've already seen it once live here. Sit and watch it at home. Just watch me do that problem once. Then pause the thing or go back or shut it off or close your laptop or whatever it is, and then try it by yourself. Try it without any help whatsoever. If you get stuck, then you can always go back and look. All right? That's what you should be doing. Is anybody going to be doing that? Yes. I hope so. Let's do another one. We got one more. I got like 3 minutes. I got 3 minutes. I am trying to help you out. Let me just finish this. I don't have any time to answer any questions. I'm sorry. I just want to get this done because you are going to see this on your quiz. Oops, I don't want to do that yet. Sorry.
Is the other class a better version of this?
They listen a whole lot better, I'll tell you that much. Well, they did today anyway. I'll say that. Wait a minute. Well, any class when they listen is good. All right, here we go. I'm going to do this a little quicker. It's on video. So that's 3y degrees. This is 2x plus 5 degrees. This angle right there. This one is x. This is 2y. And this is y plus 5. All right, so we got to figure out what's equal to what. Look at the 3y and look at the 2x plus 5. I'm not going to go through it, okay, but you should see that they equal each other, don't they? So what do? Right, 2x plus 5 equal to what? 3y, okay? What else?
Check the common denominator.
That's it. Y plus 5 is equal to x. So watch. I'm going to say x. Let's do this in white. No, I'm not taking homework. Why are you doing that? I'm still working. I'm still doing stuff. Sit down. Okay, everybody look. I got like 2 minutes. Everybody watch. It's going to be on the quiz. Not that makes any difference to you guys. So x equals y plus 5. So I'm going to take y plus 5 and put it where? In for that x. There's no elimination on this one. This is just plain substitution. So I'm going to take what x is equal to and put it in for this, because that's what x is equal to. Now, what am I going to do? Instead of writing 2x, I'm going to write 2 times y plus 5, which equals 3y. And now you do the math. This is 2y plus 10. Subtract a 2y from both sides. Shh. Let me finish this, please.
You don't want it.
3y minus 2y is y equals what? 10. So y is 10. How do I solve for x? Well, look, use this one right here. X is equal to y plus 5. So x is equal to, right, 10 plus 5. So x is 15. So that is how you solve that. All right, my goodness. All right, you got it on video, so watch it.
Thank you, Mr. Herman.
Sure.